I had 0 success in recording my second half of the class for some reason. Okay, so let's see what we would do if we are doing this final query, right? So find all students who have taken a class with Quentin Coldwater. Okay. So one thing that I know that helps is kind of draw a little graph of who's doing what. So I need to go to students to find that this is Quentin. Okay. Then what do I need to do next? I need to find a class that he takes, right? So I need to go from here to transcript that Quentin is taking. All right. So far, so good. So what is the next thing I need to do? I find the tuple for Quentin, join the transcript to find classes that he took. At this point, I can do select to find all classes that he took, right? Okay, but I am not done yet. What is the next thing I need to do? Right, same thing? Yeah. Find all people who took those classes, right? So go back to transcript a second time. Okay, find people in same class. Okay. So the point is that this is a join on student, right? Whereas this is a join on per class. Then what is the next thing I need to do? I need to go from this transcript to student again to find the name of these students, right? So go back to students to find now the name of the students who are in this one. So let's call this S1, T1, T2, and S2, right? So S1 is for Quentin, T1 is for his classes, T2 is the people in those classes, and then S2 is students. So this is now going to be a join on student. Okay? So like if you were doing degree of Kevin Bacon, this is exactly the kind of query you have to do, right? So you have to find a person, so you have to find, this would be Kevin Bacon, this would be a movie with Kevin Bacon. Okay, nobody cares about Kevin Bacon anymore. He was not even mentioned, but that's okay. So who do we do now? Who's the hot person that's in every single movie? What's the name of the guy? Oscar Isaac, right? So you know, right? So now he's gonna be the one. So Kevin Bacon tuple. Find the movies that Kevin Bacon is in. Find all other people in those movies, and then return their name. Right? It would be the same exact query. So let's write that down. So we said we're going to call this S1, transcript T1, transcript T2, and students S2. Come on. Okay. Now I have to write my join conditions. So S1.id is equal to T1.studentID, and T1. What was it? Course ID is equal to T2.course ID, and T1.semester is equal to T2.semester, and T1.year is equal to T2.year, and T1.section, God help me, is equal to T2.section. All right. So T1 and T2 are for the same course, but different students. Okay, we will get to that. And T2.student ID is equal to S2.id. Okay. Now we have a few other things. We want the T1 and T2 to be different. We don't want to return the same student. So you can say s1.id is not equal to s2.id. And we want s1.name to be Quentin. So I have to say like. Okay, am I done? I believe I am. So now I want to return distinct because there could be more than one class that they are together with, s2.id and s2.name. Okay. Technically, this will return the same result whether I have distinct or not, but the distinct is the correct query to write in this case. Okay, let's see if that runs. Okay, in fact, that is Alice Quinn. Okay, so we can try and see, for example, for different people. So this should hopefully return different results. Okay. So overall, I do feel it's correct, but whenever you write a query, always go through and look at the join conditions first, and then look at other things that you may want, right? Any questions? So, this is why you're doing the homework. You will get comfortable with doing this, but always think about what is the relations that I absolutely need, and don't put extras. Even though sometimes your query is correct, it is still less efficient, right? And we will see various different ways to write the same query, but I like writing it as simple as possible, like this, without any extra things, because this is the simplest query to optimize. Okay? Generally, you have the sense that I'm going to write the query in such a way that it's going to be faster than what the database can come up with. Okay? Turns out that 95% of the time you will be wrong. But the 5% of the time you could be right. Okay? So the simpler queries are better, and we will talk about why more and more as time goes on. Okay, so basically all that we have done so far is select, project, join, right? Project, join, and Cartesian product. So what was the next thing in relational algebra? Set operations, right? So you can do set operations. And for set operations, you have to basically write SQL queries and take their union. So you actually have two types of operators. You have set operations and bag operations. Okay. The point is that your SQL output may or may not contain duplicates, but regardless, if you were to take the union of two queries, it will always return you a set of common values. If you want to retain the duplicate values, you can do what's called union all. Same with intersect. If you wanted to keep the common values, you can have intersect all. And set the difference is called except, and in this case, except all. Okay, so both are possible. Let's do a simple example just to see. So I'm going to create two tables. One I'm going to call A1. And I'm going to insert 1, 2, 2, 3, and 3. Okay. You can have duplicate values if you don't have a primary key. And I'm going to create a second one. I'm going to call that one A2. And to A2, I'm going to insert this. Okay. So what you can do is you can take two queries and you can take their union. So if I were to say select star from, well, let's just say select ID from A1, union select ID from A2, okay? So take everything in A1 and everything in A2, but since it's a union, it will actually remove duplicates. You're going to get 1, 2, and 3. If I, in fact, instead of this, that union all, that is the bag union, which will actually take everything in one, 6 rows and 10 rows and 4 rows, and it will return you everything. Okay? Okay, let's go back to this. So similarly, if I were to take intersect, only values that are in common are 2 and 3. If I were to do intersect all, I should get 2 values of 3 and 1 value of 2, right? Similarly, if you were to do except, what value is in A1 but not in A2? 1. So I will only get 1. If you were to do except all, okay, this is the back, difference, right? So here you have all of this, and from that you subtract all the 2s, 2 3s, and then you will have to return whatever is, oh, there we go, is left, which is this. Okay? So the reason that the way it is written is a little different, right? You have an SQL and a set operation in between, and you can have many of those. If you have many of them, of course, use parentheses, right? So if you have, select from where, union, select from where, except select from where. Okay, so basically this would mean that you have to figure out what the precedence is. I would assume it's left to right by default, right? So, if it could be like this first and then this, if you want it to be different, then put parentheses, right? If you wanted that, you do this first and then that would be fine. Okay. All right, so let's do a few examples just so that you can get comfortable with this. Find the name of all students who have never received an A grade. Okay. So if you think about relational algebra, this kind of query would involve what set operation? Set difference, okay? Now, it's a very common mistake that when you hear this, you will go and find in transcript a grade that is not A, right? And then return the name of the student. That does not guarantee that there is no other tuple for the same student with an A grade. So the only really correct way to write an answer to a query like this, whenever you have never, is to use set subtraction. So ultimately what I want is find all students. Okay, this is query 1. And find students who have received an A. This is query 2. And then do Q1 minus except Q2. right? This is how I would like to solve it. So I need to write two SQL statements. One has to be about students who have all students, and the second is going to be the students who received an A grade. Okay, so all right, so this is the first query. And since I'm going to do set subtraction, even though I'm interested in name, I'm also going to return ID and name because, again, if two people have the same name, I want to extract the correct ID and name, right? The thing that identifies a student is ID. Even though I'm returning name, I still want to have ID and name. So how do I find students who received an A? Which relation? So I can go to transcript T, where I can say that grade is like an A grade, like this. Okay, modifiers are allowed. I don't know if I have modifiers in the database. And then I can return student ID. These are all the students who have received an A. And take the set subtraction. Questions, comments? Okay, let's run this and see. Okay, what's happening?
It's trying to subtract a, so the first tuple is of 2 columns, but the second one is only 1 column, so it can't be a second.
Right, they are not the same schema. This one is 2 columns, this one is 1 column. In relational algebra, I was torturing you. I call this set compatibility, union compatibility, right? You cannot do a set operation unless they are the same schema. In relational, in SQL, you're a little bit, it's a little bit easier because you don't have to rename this as ID, but you have to have the same number of columns, right? So if you're comparing 2 column to 2 column, you have to have the same number of columns. So that means for this one, I also have to have student S, do my join first. Okay, and then here I can return like this. Okay, now this is going to be correct. Okay. So anytime you have a set or bag operation, always think about what is the conditions that it requires, and then you can write it. Now, union is a little bit more challenging because some queries that require union are just basically a condition that can be written in the where clause, right? So find all students who have received an A or a B, right? You can check by looking at just the tuple. If you want to find students who have taken a class from Professor Fogg, something like find all students who have taken a class from Professor Fogg, or remember, union generally means an or who have never taken, or who have no GPA. Okay? So now you are in kind of a gray area. So you can try to see how far you can get. So you can try to write it in the union. That's easy to do, right? So you can say something like, actually, I'm going to copy and paste the class, the one with Professor Fogg here. There we go. These are all the students who have taken a class That fog. That's you. Okay, so these are all students who've taken a class with Professor Fogg. Okay, or have no GPA. So I do a query and then write a union. So I say select s.id, s.name from students S, where s.gpa is null, union. So now it's a union, so I don't need this. Okay? So I can write this long query like this. Or you can ask, can I just put an OR statement? Can I put an OR statement to get the same result? So, well, I can try. So I can say, okay, let's we don't want that. Okay. So, where all of this is true for a student, or s.gpa is null, and it's return the state. Okay. So my claim is that this is probably correct as well as the other one, but this may be grossly inefficient because you have this massive join, but for some tuples you construct this huge Cartesian product, but you only care about one attribute, not the join. Whereas in this one, you actually do two simple queries. Well, this is not as simple, but still it's a simpler query. Okay? So there are two things. That in this case, you don't need a union, but the union may be much faster. In fact, older versions of Postgres were notoriously bad for OR queries. Taking something that's an OR query and writing it at union would make it much, much faster in general. So you have to decide when it is the right time to do this, but there are queries for which you don't need union. Intersection, similar. Often queries that you write with intersection, you can also write using join, right? So just keep this in mind, that there are two basic questions that you need to ask. Union can sometimes be written with an OR condition in where. Intersection often can be written as a union, as a join. Okay, but not always. Okay, not always, but sometimes it's possible. Except there is no equivalent. No equivalent so far, except when we start to learn things like outer joins, okay, which we will do on Thursday. For now, let's assume that you do need it, but there is a way to get around that by counting and outer joins and so on. But sometimes it's much more efficient to use the set operators than the others. Okay? Any questions so far? All right, I'm charging ahead. Next, we are going to talk about aggregates. So you can take a query that returns a set of tuples and then aggregate the tuples across different aggregate functions. And the aggregate functions are very, very, there are good number of them. So for example, you can count the number of tuples. You can find the min and max value of an attribute. You can count for an attribute, which would actually count the number of values for that attribute. That's right. So it will disregard the null values. And you can do things like sum of attributes, average of attributes, standard deviation of attributes. Now, if you do anything at all with Excel, in Excel there's a single D, and in SQL there are two Ds, which is extremely confusing. So, and then there are actually operations that return. There are kind of different ones that are new in 9.4 and 9.5 for Postgres, but I don't think we need to worry about that right now. But if you're interested, you can start to learn about those. So let's try to write a simple query and then start from there. So I want to find total number of credits passed by, let's say, Elliot. Okay. As well as total number of courses. Okay. So, for example, what I can do is I can first find all the tuples that satisfy my condition. So I want to return, for example, I also need to find how many credits. For that, I need classes, unfortunately. Nope, courses. All right, that's easier. Okay, so how do I find the course code? I need to do that whole join, don't I? Oh, yeah. So I need to actually do classes, see? And then courses, C1. Is that really correct? Okay, luckily we have cut and paste. Because I have course ID, but I don't have credits here. Well, let's see, I have classes. Is the same course ID? Oh yeah, it's the same. Okay, I don't need this. Okay, so I can do this. Thank God for that. So I don't need this stuff, right? Okay. All right, so I have transcript courses for the same course ID. So I can return C dot course name, C dot credits, T dot grade. So it's actually called ID, I believe. All right, so you have, basically this person has taken 6 classes, right? These are the credits for this. These are the grades, but there is no grade for the last one, right? So what I can do is now I can take all these values and aggregate. So I can, for example, count how many courses that he has taken. So, for example, I can say count star as num courses taken. Okay. I can also count t.grade as num courses completed. Okay. It's not exactly right, we will talk about. I can do sum of credits as num credits attempted. Okay, something like this. Now what I cannot do though I can now take the whole relation and I can aggregate over all column, but I cannot return any other attribute. All I can return is an aggregate. Okay? I cannot return a single value from the tuples because I've now summarized this whole thing. So this is what I get, that the person has taken 6 courses, 5 are completed, and number of credits attempted 23. Now what would happen if the person has taken the same course twice, right? This may return it multiple times. We need to have a way to exclude those. That will turn out to be a complex query, right? Like something involving an except. So we will talk about that on Thursday. The other thing is that this doesn't take into account like your grade can be I. In fact, you cannot really write an if statement in the select. You can, but first work with the very restricted version of it, and then we will see all these other things, right? So there are ways that this query may not be right if I have incompletes, if I have multiple takes, then I have to actually write a more complex query to exclude those, something using except. Okay? So this is basically the basic idea of an aggregate. But the aggregates become more interesting if you actually start to group by different attributes. So you can actually group by a given attribute. So for example, I can group by student ID from transcript. Okay. So that means take all the tuples in transcript and create groups for each separate student. Right? So this will be tuples for one student. Student ID equals 1. This will be for student ID equals 2. And this will be student ID equals 3. Right? Basically take all the tuples in transcript and partition it into groups of tuples based on a condition. You can group by a single attribute or you can group by multiple attributes. That is okay. And if you have multiple attributes, then for every possible combination of those, you create a group. Now, at this point, you don't have something SQL can work with because I don't have any way to return groups, which apparently is now incorrect in 9.4, but we'll put that aside. Okay. So now what I want to do is return a single tuple for each group in the select. So select. In the select, I want to return a single tuple for each group. Okay. So if I'm returning a single tuple for each group, there are a couple of things I can return. I can return their ID because their ID is unique for each group, right? I grouped by ID, so the ID is unique. So you can return student ID because it is a grouping attribute. Then you can return other things like aggregates over the whole group. So take all the tuples here and then, for example, count how many there are. So any aggregate over the group now can follow the attributes. That means the thing that I just did for one student, I can do for all the students by grouping by the student ID. So I can take the same query. Okay. Now I want to return the same for each student. Okay, so in fact, okay, I don't want to select a certain student. because I actually want to return the name of the student as well as this information, but for each student. Okay? Now, if you were to run this query, so let's run this for a second. Okay. It will tell you explicitly that it won't work because column s.id must appear in group by. You cannot return an attribute unless you group by that attribute. Okay? So that means I actually have to add this new thing called group by s.id. Okay? Now I'm finding the same information, but I'm finding it for every student. Okay? But it did not ask me to group by name, even though I'm returning name. It didn't ask me to group by name, it asked me to group by ID. Why is that the case?
ID should be by name.
Because it's the primary key, right? So do we get that? Now, interestingly enough, this didn't used to be true. So if you actually run Postgres 9.0, I don't know if that's, I mean, in an earlier enough version of Postgres, this was not true. This is actually something they've thrown in. It's a good feature to have that they check the constraint, but it's not guaranteed that they would. Okay? So this is basically going to be specific. If they don't check it, then they will give you an error that you did not group by s.9. What happens if I add? What happens if I add s.name here? Will it change the results? Okay. The results are the same. Because if I group by ID and name, the groups don't change, right? Because given the ID, the name is the same. You don't have ID of one with one name and ID of one with another name, right? So since the group did not change, the result did not change. Now, this is the safer query, right? The one that has everything that you return in the group by is the safer query, unless you have the mental, focus to know that since name implies ID, I don't need to put it in group by. But beware that whatever database you use may not support that, right? It just means that they have to check it.
So I was just wondering, so if you run if you run the same query 2 different times, the result should be exactly the same, or can the result vary? Like
Depends if your database has changed, the result may vary.
I mean, like it's still the same tuples, but they're in different order. Because
Right, the order we will see.
okay.
Right, so you may get different order because of different reasons. Yes. So often, when you write queries like this, you want to enforce an ordering, right? But ordering is actually expensive. Okay. So if you never care about the ordering, then don't order, right? But we will see that next. Okay. But do you have any questions about this? Okay. So you first construct a relation. Then you group by what you need to return by with the mental focus of what you're trying to accomplish. And then you do the select. So here, you can only return things that are unique with respect to what you group by. Okay? But the safer thing is group by what you're returning so that you know it's going to work in everyone. I was actually surprised this worked because it didn't work when I was teaching this last time. So, that's why we tried. Okay, so these are the harder things. So, for example, I can now have a condition that instead of returning every single student, I only want to return the students for which the number of courses is greater than 2. So I don't want to return these 2, but I want to return these, right? So I want to return students for which the number of courses is greater than 2. You cannot write that in the where statement because in the where you're looking at a single tuple. You're not looking at everything in a group. So when you have a condition that applies to a group, you basically use the having statement. Okay. So generally, if you are using having, then you need to really have some sort of an aggregate, right? Often, this involves an aggregate. So let's say find students with at least 2 or more classes. Let's say even more so, 2 or more completed classes, right? So now I do group by, but I don't want to return every single group. I only want to return the groups where the count is greater than or equal to 2. And I am not interested in every single student, but I'm only interested in students who have completed more than 2 courses. So what I need to do is that the number of grades completed should be greater than or equal to 2. Okay? So the having will basically eliminate certain groups, and don't write conditions that you can write in the where clause in the having part. This is for things that are aggregates, because you want to reduce as much as you can in the where so that in the having you actually are eliminating as much as possible. All right, so 2 more simple things. You can take a query and you can sort the results by an attribute. So for example, you can order them by address, descending, and year ascending. Okay. So what it will do is, I guess it makes more sense to do it the other way. So it will first order by the first one. Then you can break this, you can break ties by a secondary thing, for example, ID descending. You can limit the number of tuples returned by a limit statement. That means after you construct the output, you can say, after the first 2 tuples, stop producing more tuples. Okay? So this is basically kind of the main SQL. So now this is the most important part of this class. Okay? Now that we have seen this all, we have to go back and see how this all comes together. Okay? Now this is the picture that you have to keep in mind when you're writing queries. Okay? So we have select from where group by having union select from where group by having. All right, I'm running out of space on this one. Order by and potentially limit. Okay. It is possible that you may have a query that has all of these. Okay. So here is how it works, and this is going to be very important because it will determine when your query is correct or not. So we know that you start from, construct where, go to group by, followed by having, and then you construct select, right? And then you do the same for every query separately. Okay. Now that you have these 2, the next thing you do is you take the union. Okay. So if you have multiple ones, you apply the set operations. If there are parentheses, you use that for preference. And then you go to order by, and then you go to limit. Okay. reason why this is important is that it will change a lot of the queries that we write. For example, can I say in having num courses completed is greater than 2? Will this work? Yes?
No, because non-courses completed hasn't been defined yet.
Right, because it's actually going to be after. So it will actually give you an error like this. Okay. The column non-completed does not exist. Right? So remember that it has not yet been constructed because that's the last thing you are going to do. In the same way, if you have a union, right? So you have to first construct those, and then when you union, you're going to get a new relation. And that new relation will have attributes. The name of the attributes, if you're going to order by them, they will have to be, that they usually come from the first relation. Okay? So this is going to be very important because while I cannot do that, I can say order by this, because by order by, that attribute has been defined because I know that order by comes after select, right? That does work. So the ordering of these attributes, the execution is important, so make sure that you have the mental image. Okay, so this is all that you need to do the homework. And on Thursday, we are going to get all sorts of fancy different things that build on top of that. So please try the homework by Thursday, at least a little bit. I will.